Right. Good morning, everyone, or good afternoon, or good evening, wherever you may be. Thanks for joining. This is session 2, day 2 for the DB2 stream at GSE UK Virtual Conference, and you're very welcome. This particular session is a recorded session by Emil Kotrich of Broadcom, and it's a session all around multi-row operations in a nutshell. So looking forward to that. If you have any questions, we'll do our best to answer them, but we will only you might need to actually email Emil yourself after the session. But okay, thanks so much, everyone. Please provide feedback at the end, and without further ado, I'll press play and hope everything works. Okay, thanks very much. Catch you later.
Hello and welcome to my session. My name is Emil Kotrč. I'm with Broadcom and I'm based in Prague, Czech Republic. Unfortunately, at the time of the conference, I'm on vacation, so I cannot present virtually. So I'll be just virtually present in this virtual event. So thank you again for watching my session. If you have any questions, I won't be able to answer them during the session, obviously, but I'm happy to answer your questions after I return. So if you have anything, please don't hesitate to ask me, to send me an email, and I'll be happy to reply as fast as I can. So my session is about multi-row operations in DB2 for z/OS. Some part of it is based on my experience when I was implementing some of the multi-row operations in one of our products, and some parts are what I have learned by experimenting and so on. So hopefully this will be useful for you. The session code is 2G. I hope that I downloaded the correct QR code. You can see it at the bottom. So let's take a look at the agenda. So I will start with a bit of history. That's what I usually like to look around and what happened in the past and why this is important and what is it about. Then I will speak mainly about multi-row inserts. And that's what I mentioned is mainly based on my personal experience. I also wrote a blog about it a few years ago about my experience, so you can find it in the references if you want to go through that. It contains a bit more details than I have in the presentation. And I will also cover multi-row fetches, and I will talk briefly about the multi-row positions operations, especially about multi-row positioned updates and deletes. At the end, I also want to speak about other considerations that might be overlooked sometimes. I mean, there are some benefits of multi-row operations, but there are also some things you need to consider before you use them. So that's what I want to cover in my last section. As an example is a locking consideration, but there are a few more. Okay. So let's start with a bit of history. So if you think about it, like SQL originated in 70s, and it is all set-based. Like if you read all those old articles and references to relational databases and SQL now how it started, it was all with the sets in mind in the background. So the operations were like set-based. If you retrieve the rows, you usually operate with a set of rows. So now what I want to talk about is here, like from the application perspective, right? So how you can retrieve all those rows, like multiple rows, how you can insert multiple rows at the same time. But in fact, the engine itself is like set-based. So DB2 for MVS back then was released, version 1 was released in 85. So everything we know was already there, like insert, update, delete, select. Then what happened for like in the context of this, or what is relevant to this presentation, is what happened in 2.3. There was, for example, this optimize for n rows that allowed to give some hints to the optimizer how to optimize for how many rows. So this is what I will mention as well. Then I will jump ahead to DB2.7, where scrollable cursors were introduced. Now I will not speak too much about scrollable cursors because I haven't used them. I have no experience with them, so it would be just about like what I have learned. Not sure how many users are using those scrollable cursors. but also there was a very nice presentation I have seen last IDAC in EMEA, where Chris Krohn was speaking about fetches, and he also mentioned a lot about the scrollable cursor. So if you are interested, maybe you have seen that, or maybe you can download and see that later if you have access. Version 7 also introduced this limited fetch, which is the clause that you can use in the select statement, the fetch first and rows only. I will discuss about this a bit more, especially about the enhancement also introduced in DB2.12. Now, the big thing happened in DB2.8. I mean, the big thing, again, relative to this presentation, and that's where the multi-row inserts and fetches were introduced. So as you can see, it's not anything new, right? So I will not speak about the brand new features introduced just last month or so. What I will be talking about are features that are there for a long time, are mature, are available for use, but still I see like many applications not using them for different reasons. I will try to explain later, but that's where this all originated. And by the way, also in my references, I will refer to some pretty old red books and books that might sound outdated, but still a lot of the things I will speak about and it's written in those books is still relevant to these days. You still need to take a look at the latest documentation to see how it really works these days, but I mean the basic principles are the same. So don't worry if you see very old red books in my references, they are still pretty valid in the context of the multi-row operations. Then in DB2.12 there were some enhancements as well. I will speak about the SQL pagination a bit because there is still some I still see some confusions about how to use that and what's the benefits, and so also again related to multi-row operations. Okay, so that's about the history. Now let's jump like why this was introduced. What's the benefit of multi-row operations? And as I said, I'm speaking now mainly about from the application perspective. The engine itself, like it can handle the sets already or multi-rows, right? But like from the application perspective. So the main benefit here is to minimize the DB2 calls. So imagine that you want to insert a number of rows, so you can insert one by one, or you can insert them in batches, like just insert these 10 rows at once, just call DB2 to insert these 10 rows, and then continue with the next batch of the rows. That's like, it will help to reduce the traffic, right? Just you will limit the number of calls to DB2. So all the interaction between you and DB2 will be minimized or will be reduced. It makes sense for local applications because you have fewer access to the database, so you will have less call to the database, to DB2, and also for distributed applications that's where it might be more relevant or maybe even more visible, because you also reduce the network operations. Like you have less network operations, the calls to DB2, especially if you are like distributed, it can be a big difference. On the other hand, as I always trying to say, there are benefits, but also there are some things you need to consider. So obviously now, like if in the multi-row operations, multiple rows are now involved, and it can have multiple or different implications. For example, can be like concurrency impact. People do not often think about it, but if you think about like how it works, if you do like multi-row fetch, now you need to think that all the rows that you fetched might be subject to some locking. So there might be some possible contentions you haven't seen before if you use like a single row fetch only. There might be also some logging and rollback impact. Imagine that you now have like a bigger unit of recovery. Maybe before you were using a single row operation, you just committed after every single insert or maybe after a few inserts. But now maybe if you have like a large batch, and so your commits will be larger. So you need to think about it as well. Of course, some diagnostics overhead, like if you do a single row operation, it's pretty simple. You just check the SQL code and you know if that operation succeeded or not. Now, if you have multiple rows involved, you need to and something fails, you need to think about like what happened. Was it all rows failed or just one? Or so you need to have proper diagnostics in your program. Now, apparently, your application needs some extra storage, right? Because before that, you had like a single host variables where you inserted from or fetched into. Now you will have multiple rows involved, so you need more storage. I mean, these days it shouldn't be a big deal, but you never know. Some legacy applications might be like tricky to update, to accommodate all this new storage. So that's what I mentioned by this application complexity and legacy applications, because I'm pretty sure that in some applications this can be a bigger effort than just like expanding the storage and involving more rows. And of course, there is one more thing to consider, which is like one of the last things, but I mean, it's pretty important. Like, what's the end? Like, how many rows shall I insert or fetch using multi-row operation? So shall it be like 10 or 1,000 or 100 or whatever? So what is the best number? And of course, there is no like answer to this. Like, you need to experiment, test yourself. But from my experience, I can tell you that even like 10 makes a huge difference compared to a single row operation. Again, if you are interested, I mentioned my blog that I wrote years ago. So I did some like pretty simple experiments. So I was showing some chart, like compare like one row operation and like there was like 10 and 100, I believe. So that you could see the benefit of 10 and then like the benefit of 100 and so on. But you can do it on your own, test with your data in your environment. So this is like in a nutshell how it works. So if I have multi-row insert, so on the left hand you can see like what happens if I'm inserting one by one. So I have like some variables, like host variables. I insert one row called to db2. Then I populate with another row. I'm calling db2 to insert and so on. On the right hand, you see what happens if I use multi-row operation, multi-row insert. So I prepare all the rows. So in this case, I have 4 rows, and I just do a single call to db2 to insert them all. Okay, so that's the biggest difference. So you see, instead of 4 calls, I will just use 1 call. On the other hand, I also need more storage now, right, to have all those 4 rows and to transfer them to db2. On the other hand is multi-row fetch, and that's like the opposite operation, right? I'm fetching into host variables or host variable arrays. And it can be also used for positioned operations like updates and deletes. I will explain later. So again, on the left hand, you see a single row operation. So I'm like fetching one row by another. So I will fetch first row, the second row, the third row, and so on, one by one. So I need like, so I will call fetch for every single row. On the right hand, I have a multi-row fetch where I just allocate the proper storage for my application. Then I prepare all the things I need. I call db2 and I just indicate, hey, I want this multi-row fetch. So I need to prepare the cursor to be able to do that. And db2 will populate all my host variables. And those are called host variable arrays. I will explain later what that means. So again, like a single call versus 4 separate calls. Okay, now let's focus on multi-row inserts. As I said, I mentioned already a few times, if you're interested into more details and like even with some code samples, please take a look into my blog, because I just really have details and code samples in C and I believe even in Java, how to do this multi-row insert. So multi-row inserts obviously can be used with insert, but also with merge. Can be static or even dynamic SQL. In the later slides, I will show you some like really sample or simple examples how to use dynamic and static SQL. So in static SQL, you just provide host variable array. That's what I mentioned. So you need to prepare all those data that will be inserted into db2 for all rows. In dynamic SQL, you need to do prepare and execute using host variable array, or if you have very dynamic application and you don't know in advance, so you can build completely the array dynamically using the descriptor SQLDA. For distributed applications, you can use like batch inserts in Java or this bulk operations in ODBC. We'll have an example about Java, but like personally, I did my experiments in like traditional applications. In my case, it was in C. So multi-row insert can be atomic or not atomic. I will talk about it a bit more details because there are a couple of details I want to mention. And now about diagnostics. So SQL CA can give you information about like if it succeeded or not, how many rows were inserted. You can see the field, which will give you the number of rows that were actually inserted. However, if you need detailed information, you need to use get diagnostics statement that will give you all the informations. And later I will show some examples. So this was, I believe, also introduced with DB28 so that it can work with those multi-row operations, because without that, SQL code and SQL CA cannot give you enough information about what really happened. So this is like, if you think about how you can insert rows into a table, you have a couple of options, right? So you can just hard code insert into my table and values like I have here. Maybe that's what you can do in your application. You can do this dynamically, statically. You can insert from a different table or view, right? So you can insert into your table using select, or you can use insert using these for n rows with host variable arrays. And that's what I will be focusing on. It's really the multi-row inserts using host variable arrays. But I have seen many other creative techniques like load, using clone tables. You can use DRDA fast load if you are loading from your workstation and so on. And for example, with this load, I have seen some examples how you can use there is a store procedure that can run DB2 utilities. So for example, some people can be very creative. Even from your application, you can run utilities using the store procedure, for instance. So that's what you can do as well. But if that's a good practice, it depends on your program, right? But I will focus on the third item, like it's the insert using host variable arrays. Now, there is one more thing before we start, and that's what you have seen on my prior slide. And the first example was using these values, right? But DB2.4z unfortunately doesn't support multiple values. So if you take a look at the example that I have at the bottom of this slide, I have like insert into some table and values, and I have like two rows that I want to insert. So this is available on DB2 LUW, even on DB2.4i, but this is not available on DB2.4z. So when I was like researching these multi-row inserts, I was like, why is that, and is it okay? Can it be implemented? So of course you can always open an AHA idea for IBM. But if you take a look into the SQL reference for cross-platform development, so there are actually only two inserts mentioned, like insert single row using values or insert multiple rows using full select. So there is nothing about multiple values, nor nothing about multi-row inserts in your application. So that's a Z specific. On the other hand, you have like LUW and I specific things. So anyway, at least good to know that there is this SQL reference for cross-platform development, because maybe in some cases you're really developing cross-platform applications. So that's where you can take a look and really make sure that your SQL will work across the platforms, at least in the DB2 family. There are some other considerations for multi-row inserts. For example, there is some upper limit for how many rows you can insert at once. So this is, I mean, it's pretty high. So I don't see a problem with that. Maybe some consideration about if you are using native SQL store procedures. So there are some limitations. You can use these operations, but I mean, I think the host variable arrays are not supported. So you need to use some different tricks. Okay. Now I've mentioned host variable arrays a lot. So what it really is. So that's like the storage where you put all your data for all the rows you want to insert, and then you call insert to do the business for you. So host variable array must be defined per each column. So for every column you want to insert, you need to have a host variable array. The first value in the array corresponds to the value for that column for the first row, and so on. The second is for the second row, and so on. So the definition apparently is language specific, depends on the language you are using. But on the diagram, I tried to like picture that what it is. So you have 3 rows in this case, and I want to insert 2 columns for each row. So I need 2 host variable arrays. That HV1 stands for host variable 1. Second one is for host variable 2. In the host variable array 1, I will have all the values for all the rows for this particular column, for column 1. For column 2, I have the host variable array 2, and I will have the values for the second column for all the rows. So if you need indicators, you need another host variable arrays for the indicators. So you would need another set of these variable arrays to indicate nulls if you want to use it in your insert. And of course, this all requires extra storage in your application. So if you are updating your existing application, it will require some rework, right? Because now likely you have a single host variable arrays, sorry, not arrays, but host variables, where you insert the data for 1 row, and then you run insert, right? Now you would need to populate more data. So here is a simple example, like I'm inserting into my table 1 values, and I have, like, as you can see, I'm inserting 3 columns. The first one is the first argument of values is my string, so it's some constant. The second is the actual host variable array, so that's where I will have all the values for the second column I want to insert. And the third column I'm inserting is current date. As you can see, it's like only 1 value, but I will explain how does it work. And then I have this clause for 3 rows, which means that I'm currently inserting 3 rows, like the constant number of rows. I can also make this like variable that I can specify for n rows, or n would be a host variable. Anyway, so as I mentioned, my string is a constant. HVA is a host variable array of 3 values, and current date is a special register. Now the difference is how it works if I have atomic or not atomic insert. Again, it will be on the next slide. So if you can take a look at the bottom in my picture, so you see what is really inserted. So I prepare all my data. My string, the constant, is actually propagated to all the rows I want to insert. Then I have this host variable array, which contains value 1, 2, 3, whatever it is. It can be numbers, strings, whatever. It depends on the type of the data. And then I have this current date. So in my case, I will likely just populate the host variable array. The rest will be done by dbt automatically. I mean, the propagation of my string and so on. I don't have to do it. I can still provide like another host variable array where I would set the strings, but I can do it this way. And then I do the insert, and dbt will insert these 3 rows for me. Now I mentioned atomic versus not atomic. This is pretty important topic. So atomic means all or nothing, actually. That actually means that if a single insert fails, all will fail and everything will be rolled back. And that's the default behavior. So this is atomic behavior. But I can also specify not atomic continuous SQL exception, which means that rows are inserted independently. So if an insert of a row fails, it can be for different reasons. I might have some constraints or whatever. So the insert itself is undone, but the processing continues with the next one, which means that it can allow like partial insert. So I can have a number of rows inserted and number of rows not inserted or rejected. Still keep in mind that insert of an individual row is always atomic, right? So you will have the row like the entirely inserted or not. By partial insert, I don't mean that you can insert half of the row. No, that's not the case. So individual row is always atomic. Right? Now, as I mentioned, so in this case, like some rows might be inserted, some might be rejected. So how do I know? And that's where Get Diagnostics can help you with tracking those individual rows. I will show you an example how you can use that. Also, keep in mind that you still need to commit at the end to make the changes permanent, right? This doesn't mean that you don't have to commit and that those that were succeeded are inserted and committed. No, they are inserted, but until you commit, they will be rollbacked if you issue rollback or if there is any other problem. So really, you need to make sure that you still need to commit at the end. So now some considerations about the atomic and not atomic. So as I mentioned, if you have atomic, it's all or nothing. So it means like it can be huge, right? So you need to optimize your number of rows, because if the very last row fails, then everything is rollback, which can be like it can be huge impact on your logging activity. So you need to think about, right? So while if you have not atomic, you might have some like inserted, some rejected. So maybe the rollback wouldn't be that big if you need so. How does it work with triggers? So for atomics, the inserts are processed as a single statement, right? Because really it's like a single statement, all or nothing. So any statement level trigger is invoked only once for the statement. Transition tables include all the rows that were inserted, right? So it's all. For not atomic, it's different because the inserts are processed separately. So any statement level trigger is processed for each inserted row, and transition tables include individual rows inserted. So really, you need to think about if you have triggers applied for your current application now, and if you want to use multi-row operations, you need to think about, shall I use atomic or not atomic, and the behavior may be different. Also, if you have this not atomic, any references to special registers or sequences are evaluated for each row, while if you have atomic, it's like for the same set. So that's what you have seen in my prior example. So the current date would be the same, I guess, unless I run across the day. But anyway, again, keep in mind that there might be some differences based on the atomic and not atomic. Also, what about application restart? As I mentioned, even if you have like not atomic, you still need to commit. But what if you want to roll back and then like whatever, because maybe some of the rows, if it's not inserted, you need to roll back because that was the very important row for some reason, or you have some other problem. So apparently the application restarts are simpler with or easier with atomic, because you know that it's all or nothing, like it's really the same number of rows are all inserted or not inserted. While if you have not atomic, you need to like check individual rows if something happened. So now more about this diagnostic. So for atomic, if any insert or if the insert of any row fails, all changes are undone, right? So you are pretty sure that everything is gone. So maybe now you can, in your application, you can do some fixes or whatever. You can correct the processing and restart, and you are pretty sure like, okay, it's again all or nothing. While if it's not atomic, you might have different SQL codes based on what happened. So if all failed, you will have this SQL code. If all were successful or inserts were successful, but there were some warnings, you get another SQL code. If at least one insert failed, you have another SQL code. And so if you get like this SQL code -253, you don't know which one. So you need to run get diagnostics to see which individual row really failed and why. Actually, at the end, you will have this in SQL CA, you have this field that shows you how many rows were actually inserted. So, and if it's less than the number of rows you try to insert, apparently there was some error. So how to use this get diagnostics? So first you can see the number of errors. So you will call get diagnostics, and with this number of errors, you will get like how many conditions or those errors were issued. And then you can have another get diagnostics call, or rather like a set of calls, maybe like a for loop, where you would check each individual condition, and you would check the SQL code and the row number, or like the row in your set that was inserted. So you would see like what was the SQL code and what was the row, so that you can see, okay, for this row, DB2 was not able to insert because, I don't know, maybe the unique rule was violated or whatever. So you can do change of the row or whatever your application needs, and then you can restart. But it's more tricky because now some rows were already inserted, right? So you need to keep that in mind. So that's why I mentioned that application restarts are much simpler with the atomic than not atomic. Okay, some DRDA considerations for multi-row inserts. So if you have a distributed application that's like, especially like if you have like a DB240S communicating to another DB240S via DRDA. So now there are some considerations. So So DB240S has some like limit for the data and control information it can pass through DRDA, which is 10 max. Also, one of the things you need to consider is that in some cases, the number of rows inserted is not known at requester, which means that the DRDA requester, if it's like a DB240S, it may not know what's really the number of rows to be inserted. And this can happen if the for n rows contains a constant, because in that case, it's like your application or precompiler knows the application, like it's in the precompiler, but the DRDA doesn't know. So in this case, the performance can be affected. Especially for this case, in the performance, DB2 performance book, they show some example and what you need to do to avoid such problems. So usually the problem can happen if you have like a large host variable array, but you are inserting less rows, but then the DRDA protocol will really try to move all the data from the host variable arrays, even if you are just inserting like a less number of rows. So it means that you should use like a small as possible host variable array. So really fit them for the number of rows you are inserting, avoid using constants in for n rows, or you can use descriptors because they are dynamic. So then the requester would know. And here is the thing, like multi-row inserts. So what is the correct number of rows? And I don't know, it really depends on your application, on your environment. So the only advice I can give you, just really experiment and benchmark on different numbers once you have your code ready. And I think this is like a less effort than if you are here. I think you made a good job of preparing your application if you make it so dynamic that you can change the number of rows easily. But I can tell you again, like even 10 compared to 1 can make a big difference. But again, you need to consider application storage requirements versus performance requirements. So now finally heading to some examples. So what if I have static SQL? In static SQL, this is pretty simple. You just need to declare host variable arrays for your application. As I mentioned, it's language specific. So if it's COBOL or C, it's different. Then you specify the host variable arrays in value clause. And then you need to specify for n rows in the insert, where n can be host variable or a constant. So apparently, if your n is higher than the size of host variable array, you will get some error. If it's less, then excessive rows are ignored. But keep in mind the DRDA consideration I mentioned before. So example at the bottom, simple insert into table values, and that's where I specify host variable array. So you see I have 3 host variable arrays for all the columns, right? For the first column, for the second column, for the third column. And again, like the first value of the host variable array 1 is the very first column of the very first row, and so on. And for n rows, specify that I really want to have a multi-row insert. Now, if I have dynamic SQL, what happens? So I need, again, like I need some dynamic host variable arrays. Then I need to prepare my statement, but I need to specify the attributes like atomic, not atomic. On the prior example, I didn't have it, so the default is atomic. Then you need to specify execute, and that's where you specify the for n rows, so for how many rows actually. So it's on the execute statement. Example is here. So I have my dynamic statement. So as you can see, I have statement equals to insert into table with values, and I have the parameter markers. Then I have this attribute for multiple rows atomic. I specify number of rows. In my case, it's 5. And then I execute SQL prepare, and that's that's where I specify the statement. It's from, and attributes. That's attributes saying that it's multi-row insert. And actually on the execute, that's where I specify the number of rows to be inserted. So you can see I have execute my insert, that's the statement name, for n rows, which is 5 in my case, using host variable array 1, host variable array 2. Okay, and those are those host variable arrays for the column 1 and column 2. Hopefully this is clear. It's just like a mock-up because this is all language dependent. Now, if you have like more advanced application and you build all the structure and runtime, then it's more tricky because you need to really build the descriptor table, the SQLDA at runtime. So, and I don't want to go into details, but again, if you are interested, take a look at my blog where I have some running example in C. So in this case, you need to prepare all the SQL DA. So it has some header. You have entries for every host variable. And there is also a special SQL var for the number of rows you want to insert. It has like in SQL DA, there is the SQL name, which can have weird values from the external perspective in the SQL name. So now there is a special value that indicates that this is entry for number of rows. And then you again like do the prepare as before. You specify the attributes if it's atomic, not atomic. And then you execute using descriptor. Again, example is below. So I have my statement, I have my attributes. So I do exec SQL prepare with attributes from the statement. And then I have execute the insert statement using the descriptor. And of course, my SQL DA needs to have proper pointers to host variable arrays. As you can see, it's in the SQL data that points to host variable arrays. Just like a shortcut, I have this HVA there again. So where I have the length of the host variable array and also the pointer to the data. And that's what builds all this structure. So if you have like a C program that allocates the memory at runtime, it's not like a memory allocated on stack or so. So you need to allocate, and you need to prepare all this SQL DA to set the pointers, lengths, and so on, and then insert. For Java, I have some example. If you have a Java application, for example, and to call from your workstation to DB2 and insert multiple rows. So you can use this prepared statement class, and you are adding the rows into a batch, and then you execute this batch. So this is how it works. So there are some Java properties. You need to make sure they are enabled. Again, there is like consideration with atomic, not atomic. Again, there is some property, and I believe the default is different than like in the static SQL and those applications. So I think that was like different, but I don't know if that has changed or is it that way. So anyway, example is at the bottom. So I have my SQL string insert into table with parameter markers. Then I prepare this statement, and then I insert those multiple rows. So, and as you can see, I'm using those setInt and setString methods, and I specify like the column. So it's like the first column, second column, and then I add it to batch. So for the first column, I'm adding like some data 1. For the second, I'm adding data 2, and then I add this to batch. And once I have like stack all the things I want to insert, so there is still no call to DB2 yet. It's just like in my application. And once I do the execute batch, that's where actually the DB2 is called. Hopefully makes sense. I mean, I know it's pretty quick, and you cannot stop me or interrupt me. Sorry about that, but still you can replay me. So there are some benefits. Okay, and pros and cons of this recording. Okay, so if there is no question at the moment, I would continue with multi-row fetches. So, and that's what I mentioned at the beginning. So it's like this opposite operation, right? Now you are like getting data from DB2 to your application, right? So multi-row fetches, they require a row set cursor. Again, can be scrollable or non-scrollable. I will not go into this scrollable business too much. I will just mention that those cursors exist, but will not speak too much about them. And fetch, multi-row fetch retrieves multiple rows, which is called row set. So you will see this terminology. This is row set. So fetch retrieve the data into host variable arrays. If you are using single row fetch, you have like just single host variables. Now you again need host variable arrays. This also allows position delete and updates. I will show you in a minute. So what is actually this row set? So row set is a group of rows for the result set that are written by a single fetch statement. So it's not the result set itself, it's a subset of the result set. The maximum size is the same as for multi-row insert, so it's 32K. And the row set is controlled by the fetch statement, so we'll show you example. Again, now you can think about partial row set, something as I mentioned before, but this is a bit different. Now we are fetching like multiple rows in one fetch call. So let's say you are like fetching 10 rows. So you are fetching 10, 10, 10, and then you're in your last fetch call, you might just get 3 rows, which is pretty valid operation because maybe there are no more data in the result set, right? So you need to think, you need to make sure that your last fetch can cope with like a partial row set, that not all rows are there. Again, I will show you how you can detect that. Also, because you have this cursor allow row sets, you can mix row and row set fetches. But be careful, I wouldn't recommend it because it can be pretty confusing, but you can still do it. Like you can do multi-row fetches combined with single row fetches. So now a bit more about the host variable arrays. The concept is the same as we discussed for insert. So now for every column, you need to have a host variable array defined, right? And the first value in the array corresponds to the value for that column for the first row and so on. If you need indicator host variables, again, at the same concept, you need to have host variable array for every column to indicate nulls or holes or maybe some other conditions. This is again definition specific, language specific, the definition. So that's why I have just this visualization, simple one. Keep in mind that again, this requires extra storage in your application, right? So before you had like a single host, a single variable, a host variable for first column, for the second column, and so on. And you just did like a single row fetch. Now you need to have more data where DB2 will save the rows. So as I mentioned, first you need to have a cursor. So if you declare cursor, there are clauses with row set positioning or without row set. So if you have this with row set, which means that this cursor can be used to retrieve single or multiple rows for each fetch. If you have without row set, it can be only used to retrieve a single row. If you try to fetch multiple rows using this cursor, you will get a SQL code, negative SQL code. Again, cursors can be scrollable or non-scrollable, and number of rows in a row set are specified in the fetch. Okay, so example of this cursor, I have cursor C1 with row set positioning, and I have this select statement. Okay. Now, fetch itself can be only embedded in a static SQL. So it sounds like a limitation, but in fact, it's not, because you can still fetch into a descriptor. So you can build again, like dynamically fetch dynamic like SQL DA structure, and you can fetch into that. So that's possible. So that can be very, very dynamic in nature. I believe there is some limitation for native SQL PL, but honestly, I don't have much experience with that, so rather double check that. Now, you have two flavors of the fetches. You can have this multi-row fetch that you just fetch next row set, right? So you specify for n rows, and you fetch the number of rows. The number of rows can be different for each fetch, by the way. So your application can vary that. Or you might have also this row set position. So you can like move, if you have these scrollable cursors, you can like take the next row set, which is the default. I believe you can go to prior row set, and so on. You have absolute row sets and so on, relative, absolute positioning, and so on. Now in fetch statement, you have this into clause that specifies either the host variable arrays, or as I mentioned, you might have the descriptor, the SQL DA structure. So what happens if you have this fetch and for n rows is missing? So then it's implicitly determined by the number of rows that were most recently specified, or it will be 1. So it might be difficult to know because you don't know what happened before. Or so That's why I think it's, if you are really using multi-row fetches, always have this for n rows in the fetch. It also makes it pretty obvious that you are using multi-row fetch. What if fetch first n row is specified in select? So, and that's a different thing, right? I mentioned the row set is not a result set, it's a subset. So fetch first n row specified in select really controls the total number of rows in the result set. And now with the row sets, you are controlling how many rows from the row set can be, from the result set, sorry, can be returned to application at one call. So if you attempt to read beyond the limit, you get SQL code 100. But again, keep in mind that the fetch statement controls, in a fetch statement for n rows, control the number of rows that are returned for a single fetch. It doesn't mean that it's the entire result set. Example is below. I have fetch next row set from this cursor for 20 rows. This 20 can be, like in my case, it's constant, but I can also have a host variable. And I'm inserting into those 3 host variable arrays, okay, for employee number, last name, and salary. Okay, so my first host variable array for employee number, I will get all the values, employee numbers for all those 20 rows. In the last name, I will have all the last names for those 20 rows and so on. Now, as I mentioned, you can mix multi-row and single row fetches. So I have an example here. So fetch next is relative to the first row of the current row set. That's like important note here. So let's say I started fetch row set for 2 rows. That's the green. So, and it returns me row 1 and 2. Then I have fetch next row set. And now I don't specify the number of rows, which I said I wouldn't take this as a good practice. But now it will be like implicit row set would be 2, because that was the prior row set. So it returns rows 3 and 4. And now I can specify fetch next. And if I don't specify explicitly a row set, it is a single row fetch. And now quiz time, okay? So if anyone knows what will be the returned row, yeah, good for you. I don't know, maybe next time we meet, just tell me your answer and you have a beer on me. Just the first one. But anyway, don't know how many of you are watching at the moment. So if there are many people, yeah, we'll see, but we will have fun. Okay, so let's think about it better, maybe to try it. Maybe you might be surprised, maybe you think it's simple, but anyway, at least think about it. I think it's interesting, but I wouldn't recommend this practice in any application, by the way. So now back to multi-row fetches. So diagnostics again. So now you need to know like what happened. So SQL code 100 will be pretty common, because if you fetch past the end of the result set, this will happen, right? On the example on the right, or on the diagram, I have, like, you see those 2 green rows and the rest is red, which means that the last fetch returned only 2 rows and the rest is like some garbage from the prior call, or if I didn't clear the data. But this is normal, right? Because maybe the number of rows really it's enough, so the result set doesn't contain more rows. So there is another SQL code if I attempt to read beyond the beginning, if I do a previous row set and so on. Again, SQL RDA3 contains the number of rows returned. So if it's 0, no rows were returned. But if it's less than the number of rows I wanted to retrieve, it indicates that the SQL code should have been 100 as well, because that's, I think, the last row set I returned. You can again use the diagnostics in a very similar way as before. So you can see if there is some problem, you can do this. You can check the number of exceptions and scan through them and so on. Also, there is a SQL code if there is a hole. That can happen if you have those scrollable cursors and you move back and forth, and there were some updates between and deletes and so on. So, but be careful with holes and these things. Now, blocking considerations, and I mentioned it. Not everyone thinks about it when you are changing our application from single row fetch to multi-row fetch, because you need to think about like now the cursor is positioned on all rows in the row set, right? That's the subset of the result set basically. And logs are held on all rows in a row set depending on the isolation level and whether the result table has been materialized or not, right? So that might be really implication for the application, even on this locking, from the locking perspective. So really be careful, because it's not just as simple that you will change your application to now fetch 1000 rows, but it may happen that you will see some problems and contentions and deadlocks and so on. So be careful. So I mentioned that I will speak also about some positioned operations. The first example here is positioned update. So if you have this row set cursor and you fetch, now you can also work with the row set. And I have two examples here. The first example will update all rows of a row set. I specify the where current off clause, which really means that, okay, I want to update all the rows of the row set. And the second example is selective. So I just specify the specific row I want to update from the row set. So in this case, it's like some row in the middle. Okay, so the n can be constant or a host variable. So I can update a specific row in a row set. Similarly, there is position delete, where you can work with the rows that you just fetched in a row set. So you can delete them all in the where current off. So really, you see that your cursor is positioned on all these three rows. So if you do this delete from where current off, all these three rows are deleted. But you can also specify for particular row that you just want to delete the second row in this case, or the middle row. For distributed applications, just pretty quickly, in Java, you can use this as well as in ODBC. I believe there is some property again to be set, and no example here. Just mention that it's possible. Just take a look into the doc if you need it for distributed applications, but it's possible for Java and ODBC. Similarly for DRDA, yeah, you need to think about the block fetch, right? DB2 uses some technique to fetch more data. So you, in order to use this block fetch, you need to use read-only unambiguous cursor. So ambiguous cursor means that DB2 cannot say if it's like for read-only or for updates also. So good practice here is always specify, if you're really just fetching data for read-only, just really say really that you are fetching for read-only. And if you are not using row set cursors, it doesn't mean that there is no DRDA blocking, in fact. So DB2 optimizes the transfer across the network, so it will really move multiple rows, but your application will only get a single row. Okay. And this is just a comment about the access path selection. You're likely aware of this fetch first n row versus optimize for n rows. If you don't mind, I will just skip that to save some time. There is some difference, like the fetch first rows really limits the number of rows in the result table, while optimize for n rows just declares the intent for the optimizer. Yeah, I want to mention this interesting example because we recently had a customer case where they were using a multi-row fetch in our application, and it performed very poorly, really. So we were investigating, and we were even able to reproduce using the DSN-TAP4 program. You know that IBM ships some sample programs, DSN-TAP2 and DSN-TAP4. And actually the DSN-TAP4 allows for multi-row fetches. So we were able to reproduce this, and we were really wondering what's going on. And then IBM replied what's going on here, that in some cases, so multi-row fetch can use parallelism. So if you have read-only cursor, it can really do the fetches in parallel, which is cool. But in some cases, this parallelism might be disabled in some cases, which means that then it can be really very slow compared to a single row fetch. So happened in our case was that we switched from this multi-row fetch to a single row fetch, and the performance was really pretty high because the DB2 was running the select and the fetches in parallel. So we were like getting the data faster, while in the multi-row fetch it was really sequential. So the performance was really very poor. So, and honestly, I was like looking into documentation where this is documented. I haven't found any good source of documentation, except if you take a look at documentation for DSN Tab 4, which is, I believe, in application programming guide. That's where they mentioned that parallelism might be disabled in the last parallel group, whatever that means, in the top level query block for a query. So really, in this case, if you see performance problems with multi-row fetches, try to use a single row fetch, and maybe that will actually perform faster. That was really new information for me. I didn't know that, and we learned something here. And now, how we get to that, we also, when we did the explain of the statement, we have seen that there was very high access degree in the explain table. So we are thinking, okay, so now when I see this and I see poor performance, maybe better to run it with a single row, and maybe that will even perform better. So there is some trade-off. So this parallelism versus multi-row fetch. So maybe you will see less benefit of multi-row fetch in this case, because DB2 disables parallelism for some reason. I don't know the technical details of this, but really this happened in the field. So sometimes even the multi-row fetch can perform poorly compared to single row fetch. Okay, and I think I have just few more minutes left, but as there is no question, I will continue. I like merge statement. It was like greatly improved in version 12. And that's where you can also use multi-row inserts. I have an example here, like you can specify host variable arrays. Just do not forget about merge, because that can be useful as well for multi-row operations. I've already mentioned concurrency and parallelism considerations. So keep in mind that if you do multi-row fetches, you might have these locks for a longer time, because now your cursor is positioned on multiple rows. It depends on your isolation level and so on. So need to be careful. Also, your unit of recovery can be bigger in case of multi-row, especially like if you have this multi-row inserts, right? Apparently, like the smaller row set, the better concurrency. So there is always some trade-off, right? So if you have like a large row set, apparently, and again based on your isolation level, the concurrency may be worse. But if you have like a single row, it will be better, right? But now we want to optimize somehow, so we need to find the proper number. That's why finding the proper n is not an easy task. Okay, I mentioned this multi-row insert position update deletes may affect the concurrency. To minimize the contention, you should have adjust the host variable array size, commit properly, and so on. So I mean, those are standard practices. Multi-row fetch may use this parallelism, as I mentioned, but in some cases this may be disabled. So keep that in mind. Something about stored procedures, don't have time for that, but I have found a nice blog, again, written a few years ago by Jen Mann when she worked for IBM, about how you can use stored procedures to make REST services multi-row. I think it's a pretty nice trick. I don't know if there is another way in these days. I don't think there was any enhancement to allow multi-row for REST services, but this was pretty cool. I found it interesting. SQL pagination, I don't have time for that, but recently I had a presentation about the SQL pagination, because there is like always confusion about the data dependent and numeric based pagination. But the diagram at the bottom depicts what is my problem with numeric based, because the numeric based means that you always read from the top. While if you have data dependent SQL pagination, you are like more optimizing the data access. So anyway, if you are interested, I had a session, so maybe I can share later the slides I had, or maybe I can have another presentation about this. I like these statements where you can select from table change reference, so you can select from deletes, inserts, updates. That's cool. I will skip that and for sake of time. Now for references, As I mentioned, you need to check the current documentation, but there is a great number of red books that speak more about these multi-row operations, especially for version 8. That's where this was introduced, but there are some more. Especially, for example, the one about resource realization and concurrency for DB29, it speaks about those considerations regarding the locking for multi-row operations. The last link is to that block I mentioned a few times. Anyway, so that's all from me. I think I'm on time. So thank you very much that you watched this presentation. Again, if you have any questions, please let me know, send me an email. I hope you enjoyed and stayed focused. As you can see on top, our twins, when they were working on their child computer, I found this picture interesting, and I found another random picture from the internet. I guess you recognize the guys at the bottom, maybe even on the top. I think you have seen them already. So anyway, hopefully you enjoyed. If you did, or even if you didn't, please, this is the evaluation form. Please submit your feedback so that I can improve next time. The code was 2G, and this is the QR code. So anyway, thanks again, and enjoy the rest of the conference. Thank you.
Okay. Thanks very much, Emil, although you can't hear me. If you have got any questions, I'm sure there's ways of contacting Emil. I've got his email somewhere, so email me or Marcus or Julia, and we'll get the questions off to Emil. So thanks so much for that. We now have a 30-minute coffee break, and back at 12, we have the next DB2 session, which is from Susan Lawson, and she's running a session on DB2 12 and 13 for ZOS database design and application performance. So that's going to be quite an in-depth session at 12. So shake up and have a bit of exercise, stretch your legs, get a coffee, and come back at 12, and we'll restart for the pre-lunch session with Susan. Thanks very much, everyone. Please do that feedback. It's session 2G. It's always good to get feedback, and we do need it to keep progressing, keep moving forward. So thanks very much, everyone, and catch you in 30 minutes.